Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will be discussing the problem asked in LeetCode Weekly Contest 4 to 5. So let's start with the first problem. So the first problem says that you are given an integer array and two integer L and R. You have to find the minimum sum of a subarray whose size is between L to R, right? And uh, and you have to return that sum of the subarray whose sum is greater than 0, and at the end return the minimum sum of all these possible valid subarrays, right? And if there is no subarray exists, just return -1, right? And we know what is subarray, so it's a contiguous non-empty sequence of element within the array. So it's a brute force problem. Let's see how we can approach it. So we are given an array of length n and two integer l and r, right? So what you can do, you can just apply a brute force, go through all possible length between L to R, and for each possible length go through all subarrays, right? Let's say this is your index I, this will be I plus len -1. Go through all possible subarray of this length and take the sum, and then take the minimum sum of among all these subarray. So your answer will be minimum of answer comma sum, right? So it's a brute force way, it will accept, because like looking at the constraint, if you see your length is up to 100, right? So what is your complexity? Your complexity, so you are going through all possible length, so order of n into, you are going through all possible subarrays of length L, that will again be complexity order of n. And now you are doing a sum, like the sum of numbers between index I to I plus len -1. So this will again take order of n. Well, there are two ways. So you can reduce this complexity of order of n to order of 1 using prefix sum. But since n is up to 100, so 100 into 100 into 100 would also get accepted, right? So let's look at the code. So this is the code of this problem. So this is your size of the array, this is my answer variable. Then what I'm doing, I'm going through all possible length between L to R. I'm going through all possible subarrays of length L, length len, whose start index is I. Then I'm doing the sum of all the numbers between I to I plus len -1. So this is the sum of the subarray whose length is len and starting index is I. Then I'm just checking if my sum is more than 0, because in the problem it says that you have to check only those sum which is positive. So update your answer and just check if there is any valid subarray or not. So if your answer is still int max, your answer is -1. It means that you didn't find any subarray of length between L to R whose sum is positive. So at the end return minus answer. So yeah, this is the code of first problem. Now let's look at the second problem. This is the second problem asked in the contest. So let's see what it says. So it says you are given two strings s and t, and both are anagram of each other and an integer k. So you have to determine whether it is possible to split the first string into k equally sized substring and then rearrange them and then concatenate them after rearranging. And you have to check whether you can create the given string t or not by rearranging and then concatenating of k equal size substring. So return true if it possible to form the string t, otherwise return false. And anagram, we know that if two strings of anagram of each other, then the frequency of each character in both the strings would be same. So anagram is formed by rearranging the characters, right? So let's see in the first test case. So the first string is abcd and the second is cdab. So k is equal to 2. So you can divide the first string into two parts, ab and cd, right? ab and cd, and if you rearrange them, So keep the second substring first and the first substring second. It would be CD and AB, and then you concatenate it, you can form CDAB, which is equals to string T. So return true for this case. Let's see how we can approach this problem. So in the problem we are given string as T and integer K. We know that we have to devise the first string. Let's say this is your string S. We have to devise this string into K substrings. So what will be the length of each substring? The length will be, let's say this is your n divided by K. So this will be the length of each substring. So right, let's say this is these are your substrings. These are your substrings. Right? These are the K number of substring, and each are having length len. Right. Then what you have to do, you have to rearrange this substring and concatenate them to get the string T. So I claim that, let's say this is your string T, right? This is your string T. You do the same process. You divide this into K number of substrings. Each are having length len. Then I claim that you can rearrange this substring and then concatenate them to form a string T if and only if the frequency of each substring in both the string are equal, right? Let's take the first case, ABCD. This is your S and CDAB. This is your string T. What we are doing, we are dividing, and K was 2. So length of each substring will be 4 divided by 2, it is 2 itself. So we divide this into two substrings of length 2, and we do the same here. Then if you look at the frequency of this substring is 1, the frequency of this substring is 1, the frequency of this substring is also 1 in this in the string T. So 1 1 1 1, the frequency of each substring in the both strings are equal. So you can do this operation to make string S is equal to 2. Actually this is exactly similar to how anagram works. In anagram what we do, we rearrange the characters, but here we will rearrange the substrings. Because in the standard anagram we rearrange the characters, so we deal with the frequency of each characters. But here, since we have substring to take care of, we will store the frequency of each substring in both the string, and then we will verify if they are equal or not. If they are equal, then just return true, otherwise return false. Right. Now let's look at the code, how we can implement it. So this is the code of the second problem. So you are given a string as T and integer K. So the length of each substring would be n divided by K, because so in the problem it says that your n is divisible by K. So this is your length. Then what I'm doing, so we have to store the frequency of each substring. So I created a map here, right? And I'm going through each possible substring of length K. So this is your string. This is your current string. I'm going through each possible substring of length K. I'm incrementing the frequency of that substring, right? And here what I'm doing, I'm decrementing the frequency of each. So first I'm checking if the frequency of each substring of length len is already present in the given map or not. If it is present, then subtract it. If it doesn't present, it means that there is no way you can get a substring from the string S which is exactly equal to the current substring. So return false here. If it is possible, then decrement the frequency and at the end return true. So here so there is two things. Let's say in the first string you found a frequency 5. In the second string you found again frequency 5. So so there is two way to check 5 equals to 5 or not. Or if you decrement it, if you do minus here 5 times, it will become 0, right? So at the end, so there is one more way to verify it. If the frequency, so either check 5 equals to 5 or check if the addition and subtraction become 0. So both will tell you whether both are equal or not. So this is the code of second problem and the explanation part. Now let's look at the third problem. This is the third problem asked in the contest. Let's see what it says. It says you are given integer array nums and three integers k, op1 and op2. You can perform some operations on the given array nums. Let's see what are those operations. So the first operation says that choose an index divided by 1 and round up to the nearest whole number. It means the seal value after dividing it by 2. And then you have to perform and you can do this operation at most op1 number of times, right? And per index you can do at most one number of operations. So per index you can decide to choose like whether to do operation or not at not more than one. So like whether you do it or not, don't do it. And the total number of operations of type 1 can be op1. And the second operation says that choose an index, subtract k from the nums if and only if the current number is more than or equals to k. And you can do this operation at most op2 number of times, and per index you can decide to choose whether to do the operation 2 or not. And so this is the most important part. You can still do both operation on the same index, but at most one each. So per index you can do both operation as well, right? So this would be your the corner case. And at the end you have to return the minimum possible sum of all the element after performing the operation, right? So let's see how we can approach this problem. So this third problem can be solved using dynamic programming. Let's see how we will approach it. Let's say you are at index I. Think about what is important so far. It is important that if you like what you are doing with this number at index I. The first case, if you don't do anything. The second case, when you do operation of type 1, you do type 1 operation. If you remember, the type 1 operation was by dividing it by 2 and changing it to the nearest whole number. And the third operation was if you do the operation of type 2. The type 2 was to subtract k from this number if your current number is more than or equals to k. And the fourth case is if you do both operation of type 1 and type 2. If you do type 1 and type 2. But the problem is, not problem actually you have to take care of two things. If you are following first T1 then T2, or you are following first T2 and then T1, because you are dividing it by 2 and then subtracting it from the k. So both may result to a different number. So you have to take care of both the cases when you are handling case 4. First check T1 and then T2, and in the second point you can check first T2 and then T1 and take the minimum of them, right? So let's see what is the state of DP. So it will be a 3D DP problem. So DP of I, J and K. So it will it says you are at index I. You have op1 operation max j, and you can do type 2 operation at max k, right? So this is your collection which you have. You are at index I. You can do operation of type 1 at max j number of time. You can do operation of type 2 at max k number of times, and such that your total sum is minimum. So in the problem it says you have to find the minimum array. So it will tell you the minimum sum, after handling all the numbers from index 0 till I. From 0 till I, if you have j max j number of type 1 operation, max k number of type 1 operation, type 2 operation, then this will tell you what is the minimum sum possible from index 0 to I, right? So let's see what is the recursive relation. So for the first test case, what will be your DP of I, J and K? DP of I, J and K will be equals to, in first test case you are not doing anything, it will be DP of I minus 1 J K plus array of I, right? Because you don't you have not done any operation with this number. If you are doing type 1 operation, it will be dp of I minus 1 j minus 1 k plus a of I divided by 2. Like, so it will be a ceil value. In this case, it will be, if you're doing type 2 operation, dp of ij equals to dp of I minus 1 j and k minus 1, because you are doing type 2 operation, plus a of I minus k. And given your current number is more than or equals to k, in the fourth test case, there are two things actually. So if you're doing this one, it will be a dp of I minus 1 j minus 1 k minus 1 plus, first do t1 operation then t2 operation. Let's say your current number is a of I, so it will be a of I divided by 2 plus, then this, like if your a of I divided by 2 is more than or equal to k, then again you subtract it, a of I by 2 minus k. So for this is when you're doing t1 first and then t2. If you are doing this operation, then it will be dp of I minus 1 j minus 1 k minus 1 plus subtract this, and given that this current number is more than or equal to k, plus if and then divide this a of I minus k divided by 2. And out of all these 1 2 3 4 5 and 6, sorry 1 2 3 4 5, like out of all these 5 options, choose the minimum, right? So yeah, this is the recursive relation. Let's see how we will write code for it. This is the code of third problem. You are given nums array k, op1 and op2. So you taken the size, the max value you have taken is 10 to the power 8, not int max, because it might leads to overflow if you do int max, because you have to do some addition, right? So it's better to be on a safer side by taking 10 to the power 8. Then I created a 3D dp n plus 1 n plus 1 n plus 1, because the max operation can be n, right? And the max index can be n minus 1, so n plus 1 n plus 1 would be good enough. Then this is your base condition. Base condition is actually to taking care of the first number in the array, like the number 0, right? So here you are going through all possible of like number of operation for type 1. This is you are going for all possible number of type 2. Then this is your abc, the variable. I'll tell you what these variable will store. So here you are doing type 1 operation only. If your t1 is greater than 0, it means that you can do type 1 operation. So what you do in type 1 operation, you divide the number by 2 to the nearest integer, the ceil value. So either you use standard ceil function in C++, or you can do a of I plus 1 divided by 2. It will also give you a ceil value. So this is when you do type 1 operation. So A will store type 1 operation, B will store type 2 operation, and C will store both type 1 and type 2 operation. And this is your second case when you checked whether you can do the operation or not. So t2 should be greater than 0, and then you checked if your current number is at least k. If both are if both conditions are true, then you can do type 2 operation. Then what will be your b? B will be nums of 0 minus k. You subtracted k. Then in the third case, you checked if you can do both operations. So your t1 should be more than 0, your t2 should be more than 0, and nums of 0 should be at least k. If all the condition holds true, it means that you can do both operations. So let's do that. So there are two options. First do type 1 operation first, then type 2, or type 2 first and then type 1. So this is when you do type 1 first, you divided it by 2 first, because A will stored after division. So this is your type 1 operation first, then you subtracted k if the value is more than k. And in the second case, what you did, you first subtracted. So B will stored after subtraction. So you have subtracted it and then you divided it by 2. So this is your type 2 first and then type 1. And your C will store the minimum of these two, right? And then you update the dp value. Dp of 0, t1, t2 is minimum of. So nums of 0, don't do anything. A when you do type 1 only, B when you do type 2 only, and C is when you do both operation on the same number, right? Type 1 and type 2. So this is for your base condition. Now let's build the dp for other numbers, for numbers from like index 1 to n minus 1. So it would be almost similar. Let's say you're going through all the indexes from 1 to n minus 1. You are going through all possible t1 value, all possible t2 value. So t1 is for number of type 1 operation, t2 is number of type 2 operation. You initialize dp of I t1 t2 initially at infinity. This is your abc variable, which is same as the previous base condition. Then you checked type 1 operation, like so here you are doing type 1 operation only, here you are doing type 2 operation only, here you are doing both operation, and here you are doing type 1 first and then type 2, here you are doing type 2 first and then type 1. You're taking minimum, which is exactly same as what is explained in the base condition. And here you are updating the dp value, you are building the dp. Let's see here this so dp of I t1 t2 will be I minus 1 t1 t2 plus nums of I, means you are not doing any operation. Here you are checking if you can do the operation of type 1. Then you update the dp with dp of I minus 1 t1 minus 1, because 1 less, because you are doing type 1 operation at the current index. So for previous it would be t1 minus 1, 1 less, because you have done one operation for this of type 1. So this is your type 1 operation. Then this is your dp of I minus 1 t1 t2 minus 1, because you are doing type 2 operation plus b. And here you are doing both operation. So just check if you can do by checking t1 must be at least 1, t2 must be at least 1. Then you updated the dp of I t1 t2 as I minus 1 t1 minus 1 and t2 minus 1, because 1 less for both, because you have done both operation, and then plus c. So c will take care of order, what is the order in which you are doing the both operation, and update the dp, and at the end return dp of n minus 1. Like, so n minus 1 is for all the numbers in the given array 0 to n minus 1. op1 is the max operation of type 1 and op2 is max operation of type 2. So return dp of n minus 1, op1 and op2. So this is the code of third problem. Like, I'll post the solution of fourth problem soon. I couldn't get it accepted during the contest. Yeah, so if you find the video helpful, please like and subscribe to my channel. Thanks for watching.